As Dave has already introduced me, my name is Darren Swan, and tonight I'm going to be showing a little bit about the upcoming technology called Blazor coming out of Microsoft, which comes in two different flavors. You can either do server-side Blazor through SignalR and WebSockets, which is not actually what I'm going to be covering tonight because that's the less fun way of doing things. The way I'm going to be covering it tonight is the other flavor, which is WebAssembly, which is compiled code that's actually running in the browser. And so what Blazor does is allow you to run .NET Core compiled code in the browser. And it runs against the Mono framework that has been optimized to run as a WebAssembly framework. One of the really neat things about it is that you can, in theory, be able to completely replace all the JavaScript in your front-end application with a WebAssembly setup and be able to essentially use the same technology stack you would normally have used for your web API or web backend through ASP.NET, except be able to use that as a front-end technology and do a lot of really cool things that you would otherwise wouldn't be able to do in the browser. The demo I'm going to be showing tonight, I have a simple calendar here that I put together using some HTML, CSS, and JavaScript. Real simple calendar. I do believe the dates are finally correct. And this should look like November's calendar. But the JavaScript for this is just simply grabbing the day, the month and getting the first day of the month, so that way I can offset the first row of the calendar to make sure it shows up on the correct day of the week. Just a little bit of CSS to make it look nice and to lay out the grid, and then a nice hefty amount of div tags to create the actual calendar. You know, in JavaScript, this is really simple, really straightforward, but I really hate working with datetime objects in JavaScript just because it's just not, it doesn't sync with me. All of my experience comes from working in the Microsoft side of things, so doing things in C#, and so I've grown accustomed to using the datetime object in C#, and so I prefer that one. So what I've done, just as a little demo, is I have this here, and this is the, we have the datetime.now, which is C#'s version of getting your date, and this one is just giving you the text month, and this line right here. But before I skip to this, I just want to show you, this is the default sample that shows up. This is what this file looked like before I started, and we can just debug it real quick to actually show you what it looks like in the browser running in Google Chrome. It does take a second longer to load because you are loading a binary file as opposed to the text files of JavaScript. But yeah, this right here, this entire thing is done in C# and HTML. But looking at the code,
you don't walk in all, you know that, don't you?
you're paying for part.
I thought you were pausing for applause there, but I'm just reading the room.
So Darren, would you use this to, I noticed like when you were clicking, of course it's a very simple example, but the URL didn't change, so is this like used for a single page application, or can it be used for a site that has many URLs?
All of the above. What it does is it's using the Razor syntax that Microsoft debuted when they went with MVC.
Okay, I was going to ask about that too because I don't know what a Razor file is. So can you talk about that for a second?
Yeah, the Razor file's here. So if you look, come here. The files have a .razor extension, which is different from the way MVC does things. MVC has a .cshtml or .bbhtml depending on what language you're using. The syntax inside the file is the same. Why they chose .razor, I mean, they could have called it .blazor given that the language is called, or the framework is called
So
Blazor.
the Razor files are like at least presently tied to Blazor, or would you wouldn't encounter Razor files outside of Blazor is what you're saying?
At the moment, moment, you're not going to run into a Razor file outside of Blazor, but you could use the CS HTML files inside Blazor, but there's a weird workaround for that.
Okay.
Because .razor files are they're not actually a single file, but inside Visual Studio and the File Explorer and whatnot, that's how they're represented. But ultimately, they're a dynamically generated C# file that happens in the background. But in the case of what I'm doing here, a lot of this HTML is exactly the same. I have my day of the week div, I have my date grid div, but instead of listing out all those div tags for all the days of the week, which I could have done in JavaScript to generate those as well, I'm actually using the C#, the for syntax to just be able to just generate it based off of the number of days in a month. So if we end up in February, I don't have to adjust the HTML to only have 28 or 29 days. It'll just automatically know there's only 28 or 29 days, depending on if we're in a leap year or not. And then I also have a few little helper methods down here that help me figure out if it's the first day, of the first week of the month, or if it's the first day of the month. And just to give you a brief demonstration of this. Which, by the way, this is actually both compiling and loading the application when we do this. See, oh, wow, it did not scale well with my screen resolution there. But it generated a nice little calendar for us. And I know this is a lot of overkill to just replace like 4 lines of JavaScript with probably 200 or 300 lines of C#, but when it comes to working with the date time objects, C# is my preferred language when it comes to that. So rather than having to go out and learn a new language, which I do know JavaScript, and there is a JavaScript interop with Blazor, so that way when you have your code that's been compiled and shipped out to the browser, it can still interact with the JavaScript APIs and things that the browser gives you, and you can write your own JavaScript that wraps around your WebAssembly. But that's taking things to a more advanced level. But with Blazor, you pretty much have any, at least from my experience so far, any library that you can find that is .NET Standard 2.0 or 2.1 compatible, you can use that in the browser with the Blazor syntax, which any of the .NET Core libraries, which includes like the OpenXML libraries from the Office team that allow you to edit and manipulate Word documents, Excel documents, PowerPoint, you could do those just right in the browser as an application that runs in the browser. And also with the newer ways that things are happening with like iOS and Android, where you can tag websites as icons on your home screen or whatnot and have localized applications with local storage, you can essentially create your own mobile apps that don't have to connect back to the cloud except for the very first time you load them and then the occasional update. So you can do with JavaScript, it would be an offline web page, but you could do the exact same thing, but be a lot more powerful, a lot more verbose about it. So, I said half an hour, 45 minutes. Does 10 minutes count?
Well, and so you're doing this all in Visual Studio. What
Yes.
mod? So you just loaded in a Blazor module or something?
Visual Studio Code, though, right?
No, this is Visual Studio.
Oh, okay.
I could have done this in Visual Studio Code because it's actually just a .NET template. So I could have done this completely off with the command line using the .NET new command in PowerShell. Just do .NET new, and I believe it's WASM is the name of the template, which is for WebAssembly. Now Blazor does also have a SignalR flavor, which is the WebSockets, but for that one, everything is rendered server side, everything, and then your DOM changes are streamed to the client in order to get them to update client side. So you're instead of like traditional like ASP.NET web forms where you have the disconnect, and you have that state object that has to get passed back and forth. With the SignalR stuff, your state is entirely server-side. The entire application is server-side. There is nothing that goes to the client except for a custom JavaScript library that's part of the Blazor, that then connects back to the server to do the SignalR connection and just streams DOM changes down to your browser. Personally, I don't really care for that particular approach, because when you start talking about cloud and Azure and things like that, you start talking about your CPU cycles and how much do your CPU cycles cost, and how much your memory and things like that in the cloud, because you pay for those resources. That has the potential to get pricey quickly.
Yeah, I like that, doing it on the front end
Yeah.
aspect.
But the catch to that, though, is that now the Mono framework library that gets loaded initially is 1.4 megabytes in size. So that's the very first thing that gets downloaded as part of your app, and then your app's DLLs get downloaded to it. And so whatever the size of your app's DLLs, including the libraries and things, you get very easily balloon out in size in terms of what's getting downloaded to the client.
So it sounds like this would be more useful if you're, this is kind of what I was asking before, like building some kind of application, right? Like if I'm creating like a marketing website, you know, I don't want to lose traffic because my load times are too long.
Right.
Right. So I don't think I could afford that on a marketing website, but if I'm building an application where people are logging
Right,
in
if you're
and
trying to
then
build like a
something
rich
to it.
web application,
Yeah.
like if you're like, for instance, if you're trying to reproduce Microsoft Office, except
Right.
in your browser, this would be a good route for that. But if you're just trying to do a quick demo site just to show something off to somebody, I mean, unless you're trying to show something off that is reliant on a library that you want to use, you know, might be better off to just use like something quick, like a Angular app, or even just like a Wix web page or something. But that also comes down to every time, you know, depending on what it is you're trying to do, is what technology stack you're going to use.
Well, let's say I did build a marketing website, Ben's better judgment. This is what I asked my URLs, like what's the crawlability? Like is Google going to be able to come along and crawl my site and index it, or is there any reason that Blazor's going to get in the way of? I mean, like,
Blazor
Google
should-
probably isn't going to run the WebAssembly, right? Like I've heard that they run JavaScript in some cases, but
That much I haven't actually looked into yet.
okay.
I do know that there is a router built into it, so you can do it where it will actually change the URL in your URL bar,
Okay.
and be able to change things like that, and be able to hit specific pages within the WebAssembly
Well, that'd be important
application.
for crawlability, right? Because you want to have those different references show up on the Google search results page. So.
Right. So I don't know, without being able to actually execute the WebAssembly, I don't know
Yeah.
how that would work.
Hey, Darren,
Yes.
okay, if you had a little app or a little web page and it connected to the cloud somewhere, and you had a bunch of devices on your home network,
Okay.
and you're gonna check on them and do a bunch of stuff, right? Can you use the .NET security objects talking to devices on your network? Like, for example, you got some camera.
In the WebAssembly world, you're
Yeah.
still stuck in the same sandbox that the JavaScript is.
Okay.
So in terms of external network connectivity and things, it's actually explicitly looking back to the browser to do all of its HTTP client calls and things like that. So it's not using the .NET HTTP client. It's got a wrapper around what the browser natively uses. So as a programmer, to me, as a programmer, it looks exactly like the .NET HTTP client object. But under the hood, it's still using the browser to actually send all of that stuff.
Right, so
So-
all the security and everything is run through the browser?
Most of the security is yes.
Oh, okay.
You still have the ability to use things like the Microsoft's identity libraries and things like that. Those are fully available to you. And so you can do things like JWT and things like that to do your authentication and handle that straight through the WebAssembly stuff.
So given what you said, it sounds like some .NET, like if there's .NET libraries that could do like open TCP sockets, like those must fail, right? Because your web browser, I mean, that's not.
Right, because the browser won't allow for those.
Right.
And that's because, and just like if you were to try to open a TCP socket with a JavaScript application.
Well, I don't even think
in the
there's an
browser,
API to do that, right? I mean, I don't even know.
I don't know
Yeah,
either.
I don't think there is.
But I know there's JavaScript libraries that work within Node that
Oh,
can
yeah,
do that.
that makes sense.
But I know that those libraries don't work in the browser
Yeah.
because from the browser's perspective, you can't open low-lying
Sure.
Yeah, because
sockets like that.
you know this sounds a lot like ActiveX, right?
It does, except I was just demoing this in Google Chrome.
Uh-huh.
And I could demo this in Firefox, I could demo this in Opera, I could demo it in Safari.
It actually works on all the browsers, no problems?
It's because WebAssembly is not a Microsoft thing.
Okay.
WebAssembly is actually started by the Mozilla Foundation, at least my understanding of it.
Okay.
And it's a compiled runtime that runs in the browser. And it has its own like industry body following it and governing it and everything already. So, to my knowledge, at the moment, the current WASM compilers and things run against like Rust or Go or languages like that are kind of more centric towards like the Google or Mozilla stacks. Blazor is kind of Microsoft's first jump into that area.
So you could literally take server C# code and stick it in the browser? I mean, you could.
Yeah, almost
Wow.
verbatim. So, but what I was going to show, yeah, here's the JavaScript interrupt. But Telerik, DevExpress, Syncfusion, Redzen, they actually already have components that run in Blazor. So anybody who's used the Telerik libraries already has a set of components they can go out and play with if they have a Telerik subscription. But and Blazor is open source. There's another website I was going to show that has demos, but I'm not certain where that went. Oh, here it is. Awesome Blazor. But there's all kinds of documentation and things out there, and people have done demos all over the place.
It's pretty cool.
So how new is it? I mean, it must be fairly new.
It's not fully released yet.
Oh,
They're currently in Preview 2 or Preview 3, I don't really remember which. But it's supposed to be being released as part of .NET 3.1, which is rumored to be released either the beginning to middle of next month or the very, very beginning of next year.
Is that .NET Core 3.1?
Yes.
Okay.
.NET Core 3.1. But one of my favorite Blazor demos that they've done on here, where did it go?
it's a lot of demos.
Yeah, there are a lot of demos.
It's about halfway right there.
There's also a lot of videos about it too. There it is. Diablo Blazor. This is a hybrid WebAssembly and C++, or a Blazor and C++ WebAssembly application that
C++ or C#?
C++.
Okay.
The C++ bit is separate from the C# bit, but they're both being compiled into WebAssembly for this particular demo. Here it is. But this one is the one that I think is just amazing. It's literally playing Diablo, the original Diablo, in your browser. Like all the components, all the setup, all the support libraries, they're all running in your browser through a combination of Blazor and C++ through WebAssembly.
How resource intensive
Yeah.
is this?
Yeah.
Let's
I
go
mean,
look.
Chrome's pretty resource hoggy anyway.
I know Chrome's a bear on its own.
with all of my tabs I have open, Chrome is using just over a gig of memory. But performance-wise, like, my CPU is barely even okay.
Oh yeah, Mr. Freaking Core i7 running a DOS game. Come on, man.
Word rat comes out.
I mean, like, if you were to try running that on, like, an Atom processor, would you be able to do it?
That, I'll have to try it when I get home. But yeah, so after closing all those windows, yeah, Chrome has cut its memory usage in half.
So you only have Diablo running.
Yeah, I even closed all of Visual Studio too. So
So
this is the only tab I have open.
would most of that RAM usage just be from the game itself?
Well, Chrome currently has 12 processes running in the background, and I'm not sure which one's which.
Yeah.
I would assume this one.
Very low, everything's low.
I think this one is the one that's actually the tab with Diablo in it, because this is the one that keeps saying that GPIO.
We'll start the game so it's like doing more graphics.
Yeah.
Come on, man, let's do some dungeon crawling. Heck yeah. Those graphics sick, man.
And you told me you went to college not to play video games.
I never said that. That's what she said.
Gotcha.
So yeah, like it's still, you know, Chrome has jumped a little bit, but I know multiple of those processes are hitting. So
It's cool. That's a good idea. Good demo.
but yeah, so I'm a little excited about how this Blazor stuff is going. And my own personal home automation project that I've been working on, I've actually decided to scrap my Angular front end completely, and I'm writing it entirely in Blazor now. So, does anybody else have any other questions, comments?
So with Diablo, there's a multiplayer mode. That probably doesn't work, right? For the
I
reasons we already
don't
discussed.
think that works. I haven't actually tried it.
Otherwise, we could all play right now. I guess.
Everybody just open up your laptops, we're gonna all play Diablo.
These are the real questions we should be asking.
But I do know that with Blazor though, you do have access to the SignalR library, so you can do WebSockets. So in theory, you could do your TCP sockets over a WebSocket connection. But that would also require the other end to be aware of that as well.
Mhm.
So
How did he write that demo? I guess you'll have to go look at that archive.
yeah, I'm gonna have to go look. I'm gonna have to look a little deeper at that. But
That's amazing.
somebody else had. My understanding of how that particular demo was is somebody else had already imported a WebAssembly for the Diablo stuff, and then he wrapped it with the Blazor stuff to be able to get it to display. Like,
There's an interesting story. I can't remember it quite, but I read an article about it recently. Like somebody I think they built that from scratch. They like reverse engineered all the data files. I don't think they have the code for it.
well, that particular .dat file was the one that was used for the demo that was launched.
Yeah.
So if you went and got their demo disk to install it way back when, that's the file that you
Right.
would have had.
But I don't think that has the code. I think that's data and the engine and the code that sits around it. Somebody actually went to all the trouble to reverse engineer and build a new.
Yeah.
And maybe Blizzard actually lost the source code for the original one. There's some
Yeah,
weird
there's a lot of
story.
really weird stories around old Blizzard.
Yeah. But that's recently read an article about it. I don't know why. It wasn't related to Blazor, but about that
Yeah.
port or whatever.
Cool. Any other comments, concerns, questions, heckles?
You were expecting heckles, right?
I don't come to any of these meetups not expecting them, so.
I've trained you well.
Okay, for the record, everybody, my parents and roommate.
Yay!
Oh, should we sing happy birthday?
Yeah, I'm just
That's his dad.
Should we sing happy birthday?
It's not till tomorrow.
Oh, okay, we'll do it tomorrow then.
We'll have to come back tomorrow then.
There you
Yeah.
go.
Yeah, there's all come down here, yeah.
So Dave, we're all going to your house, right?
I'm having dinner, starts at 2.
Your dinner starts at 2?
I can't promise you a plate or a fork, but yeah, you're more than welcome to come.
Don't need one.
Well, Dan,
All right.
All right.
Thank you. All right, we're just gonna take a short break here for us to retool, and then in a couple minutes, Christopher will be up. So. Thank you.
It was actually appropriate for me to clap that time, right?
Yeah.
No,
Okay.
So what's the situation with your laptop? Did you find a adapter for the?
I had the 3-minute tutorial on AirPlay. I think I'm gonna give that a try.
Oh, okay. Okay.
We're
Do you
gonna
have
get
a demonstration?
demonstration based off of Dave
Oh,
spending
yours will
3
do
minutes
AirPlay?
online.
Yeah, I'm gonna try it right now, real quick.
All right, why don't you test that out?
Dan's card.
Is there?
I'm actually about to go get a refill, so
Are you getting more coffee?
I'm getting more soda.
Oh.
I don't drink coffee. Coffee's for adults. And I am by far not an adult.
Yeah, whatever.
Stop with condom.
Too many years.
Wow, this is what a podium looks like.
Yeah.
I've been behind a few of them already.
Yeah, I gotta go ask him. I'm
Yeah.
getting prompted for the code, but nothing's showing up on the screen.
Darren has a key to get back there, and they've got some refreshments and stuff.
How you doing there, Darren?
I'm not sure we're supposed to take every Yeah, I went to ask the dude it shows it on the list. I clicked on it, but I'm not seeing any number turn up on the screen.
No, this farm girl took a Model 3 Tesla and turned it into a truck.
How you doing?
Yeah. 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 Anyway, so she's like,
Glad you're here.
a YouTube equivalent when people would text you at 3 a.m. like, well, but it's not. Like, when you call, it's more of a, hey, can you help me pulse a number?
Had Melanie text me one morning about 3:32 to say, "Can you come over? Or you gotta work today?" I said, "Yeah, I gotta work." She said baby was awake and she just randomly texted me. And I come over her house later on that afternoon. Devin came home because it was that day it was really frigid. And I said, you didn't want me to come over when you texted me, right? She was like, oh no. I said,
Oh, I'm waiting for you to do something. You're waiting for me to do something.
You know, if she wanted me to come over, she would have told me, can you come over?
Maybe I should have asked that question
first.
Did we both get up here, stand here looking at each other?
Hey, what are you doing? Tesla Model 3.
That's my part of my demo. Okay, here, and
Back in the car.
nothing up here. Man, I need one of these for my kitchen. I was gonna ask for it, right, Earl?
Austin City Limits, I'm so sorry.
No worries.
You mean the land of the overpass?
Bonus. Cool,
That's
thanks.
known as Dallas, the land of the overpass.
I'm gonna present something first. Did you have to push did you push a button on the side?
No, I just,
Okay.
we were actually connected to the wrong,
Okay,
trying to
okay.
connect to the wrong.
No worries.
So,
I'm just gonna hook up to HDMI
Yeah.
port. I have it. It's all good.
It's all yours.
Yes, all those.
All right.
Oh, man, I forgot to turn off the camera.
All right. Well, thanks to those of you who are here tonight. So my name is Chris Cooper, and I'll tell you about myself in a minute. But the topic that I'm gonna cover in conjunction with Dave is Dave and I have been working on a commercial project for the last couple months using an ESP32 microcontroller. So what we want to talk about is one, just kind of covering what is an ESP32. If you don't know that, what is a microcontroller? A little bit about what you would need to know if you want to purchase one to your own project, and then Dave's going to walk us through just how you actually do the coding and do compilation and deploying the code to an ESP32. So just a tiny bit about me before I get started. I've spent most of my career working on enterprise software projects, and what else do I have to say about that? I've always been kind of interested in low-level programming. I think that's just the nature of kind of like when I started learning to code and so forth. And as part of that, it's sort of extended. I've always been interested in embedded programming, but that just hasn't really been where my career has happened to evolve. But I have recently had a chance to do some of that, and I've always been doing projects on the side related to embedded devices and so forth. So I guess, especially, I also should say, since we have such a small audience, if you guys have specific questions, please feel free to interrupt me, and we'll cover that, and you're welcome to shape the direction of what information I present. I mean, I hope this information is useful for you, so let me know. I guess for those who are here, who knows what a microcontroller is or understands what it is? Okay.
That's a processor, right?
This is a trick question.
No, that's not a trick question. And have any of you done anything with do you know what an ESP32 is, or does anybody know what that term?
Oh, yeah.
That's an Arduino, right?
It's a cool boy.
That's one of those Raspberry Pi things, right?
Yeah. We will talk about that. So, all right. So a couple people it seems like may not know what a microcontroller is, and so if you're new to the IoT community, this is something that's probably useful to definitely understand. So I'll just talk about that for a moment. So a microcontroller, or sometimes it's referred to as an MCU, MCU is a microcontroller unit. It's basically a system on a chip. It's a chip that has some kind of processing capability embedded in it, as well as memory and other things that you would need to have to actually build a device, interact with sensors, control different devices externally. And so if you think about that compared to like a normal desktop computer, your computer has a processor, but that processor is separate from like the memory that's soldered onto your motherboard, or separate from any firmware that's embedded in the device. You have a number of discrete components, right? And over time, the systems do get more and more integrated, but they're still distinctive pieces, as opposed to microcontroller, where that's all really encapsulated together. And the key aspect of the microcontroller, right, is you actually have some I/O pins on it that you can use to read, basically to output signals or input signals from the outside world. So, like if your Intel processor in your laptop doesn't typically have that. You don't have a way that you can wire directly into your Intel processor. And if you spend hundreds of dollars on that processor anyways, you probably don't want to do that. I'd be fearful of damaging the processor. But a great thing about microcontrollers is they tend to be very inexpensive, right? And not only that, they're very power efficient. So there's lots of devices around your house that have all sorts of embedded microcontrollers. They may run off batteries and they last for a long time, right? So it's a key thing that the microcontroller is not consuming a substantial amount of power, which is completely different than like your processor in your laptop. And the last thing to mention, and we'll dig into this a little bit more with how it relates to ESP32, but oftentimes when you're deploying code to a microcontroller, you're like programming it to the metal, basically. There's no operating system or underlying code that you're working with. You're just actually directly manipulating the state of the processor and things like that. As microcontrollers become somewhat more sophisticated, I'll talk about this in a moment too, but it starts to be a need to have a very simplistic operating system and some basic concepts that are there. But there's many microcontrollers where that's not the case. And the microcontroller we're looking at here, this is not an ESP32, but this is actually a microcontroller that's been around a long time. It's made by Atmel. They call this series AVR processors, so it's in the same family of processors that you'd find in an Arduino board. Dave has an AVR shirt, I see. So.
How much memory does it have?
Yes, that's a good question. So like this particular one has, I believe, just 512 bytes of memory, maybe less than that. Like this is an AT Tiny, so it's a very limited capacity, but they're very cheap, and and they don't use much power. It has like 512 bytes of memory, and I think it has like 2 kilobytes of flash memory basically to store code in it. So it's very limited on what you can do with this, but for certain applications it's perfect. So let's talk about an ESP32. An ESP32 is a more recent, more advanced processor, right? And as you do have more things advanced and you have more capabilities, you know, this may actually take a little bit more power. There are some trade-offs potentially. It's going to be more expensive. Like those that picture, that AT Tiny, I think you can buy individual units of those from DigiKey or something for probably 75 cents. This is a picture of the actual ESP32 chip. And the ESP32 is a microcontroller. It has a few different variants or flavors that are available, so you can get it with dual cores, you can get it with a single core. It runs up to 240 megahertz compared to like that AT Tiny chip that runs at 16 megahertz at the top end. Also, the ESP32 has what they call an ultra low power core, which is a separate processing core. You can basically put the chip to sleep, and that core can run code at a much slower pace, more limited code, but it can read certain inputs to the chip to wake it up or do things in a very low power state. But it can bring the whole chip back up if there's some event that needs to be managed or response is necessary. And compared to like the AT Tiny that we just talked about, this has 520 kilobytes of RAM inside of it. There's some restrictions on how the memory can be used, but that is the amount of memory it actually has. It's just you still have to keep in mind how much memory you have, and it can end up being a constraint. There's a capability with these chips that you can actually attach an external RAM chip to it and add another 4 megabytes of memory. And then as far as the actual flash memory, this is a little distinctive on the ESP32, is the flash memory, which is the memory where you store your code and any data that's going to persist over time. That is external to the chip itself. And you can put you can put in chips that are up to 16 megabytes. So that sort of chip you see behind the one in the front, that looks like that's probably the flash chip for this particular board that was photographed. Yes, sir?
And you mentioned BT Classic. That's just whatever Bluetooth is, right?
Yes. So that's the capability that's interesting in this device is that it has Wi-Fi built in. It can be an access point or a client. It has classic Bluetooth, right, which you typically use just to transmit data, like kind of a serial port kind of connection, and then it also has Bluetooth Low Energy, which is a different.
BLE.
Yeah, that's BLE. So. And then with this, yes.
Do you know if there's any plans in the works to add the new Bluetooth? Was it 5 or 5.1 to the ESP?
I don't know. I don't know.
What's the difference between like the older one and the new one?
Well, the one that's got the multiple antenna arrays, more precise indoor geolocation.
Well, we'll come around to this. There's a new variation of the ESP32 that has some benefits and some trade-offs, and I think we'd actually talked about this. There is some location capabilities, but I've not investigated that. So, but I don't know if that involves having more antennas or what exactly.
I think that's 5.1, if I remember correctly.
Maybe, yeah,
Give me
maybe.
the hardware,
Is there any-
I'll cobble it together.
Is there an ESP64?
There is not. There is not.
What's the difference between an ESP32 and ESP8266?
Oh,
I will
that's
come
gonna
around
be-
to that. That's a good question. But the short answer, I'll just say, the short answer is there's a device that this same company makes called an ESP8266. That's like their original in-market product, and the ESP32 has been around for a few years now. It's more capable and more powerful than the ESP8266, but those 8266 devices are definitely popular, especially in the hobbyist community. I think I've worked on some projects with the 8266, and you can run into sort of constraints with that. So I think if you're building a one-off hobbyist project, whether you spend a few, $5 or $10 is probably not particularly material. You should probably stick with the ESP32. It's just more capable and have fewer headaches. So, yeah.
About 4 years ago, I bought up a bunch of the first generation 8266s. Can I even do anything with those anymore?
They're completely usable. I worked on a project recently for a group that's making digital badges for conferences.
Okay.
And we built some badges using the 8266, and they can do a lot of the stuff the ESP32 can. They just have less memory. They don't have Bluetooth, for example.
Wait, aren't they going to be like 2 Bigfoot badges?
too
What
big.
is the
for-
size for this thing?
They're small. I mean, the
teeny tiny.
yeah. This
The ones
chip,
that-
by the way, so this chip in the picture. Yeah, I guess that's a good point. Hopefully, it'll be back up here. That's either 5 millimeters by 5 millimeters or 6 by 6.
Right.
That one's probably 6 by 6 actually. So.
But it seems like relatively big for a badge though.
Well, these are like badges that are made on a circuit board, and they have either like screens or lights or different. I mean, and sometimes they cut them out. There's a whole
Or like really fancy one.
there's a whole community that's interested in building these custom badges that they sell at conferences. So. And the ESP32. So I just explained something here. So the GPIO is general purpose input output. These are the pins you can use either as inputs or outputs.
Good save.
Maybe I won't walk over to the screen.
Those clips are there.
Oh,
Is that what
my computer's too
they
simple.
undo it? Just pull it off and put it on front.
Nice. Okay. Well, anyways, the GPIOs are the inputs and outputs that you can use. The ESP32 has like 18 that are not allocated for any special purpose. You definitely can use those. There starts to be other pins that have multiple purposes, so you can probably actually get more than 18 if you need to have some more for a particular application. There starts to be challenges, like some of the GPIO pins, there's a few that affect the boot behavior, so like if you wanted to use it, you'd have to somehow make sure it remains disconnected when you first power on the device and then have it attached. And then there's several pins that are what I call GPIs, so there's general purpose inputs. Those cannot serve as outputs. And for the purpose of inputs, they actually connect to that ultra low process or power core. So you can actually, that's like the ultra low power core can read the state of those pins to make different things happen. And then there's a bunch of sort of higher level specialized protocols, right? So this SPI or SPI, I2C, those are very common protocols. I2S is like a high speed bus for sound data. So like the badge project I worked on, we used I2S to output like an audio stream basically to an amplifier chip, and then it would go to a speaker. And then also, which is pretty cool, the ESP32 has built-in support, like half of what you need for an Ethernet connection. So you need an external chip, but you're halfway there already with like if you actually want a hardwired Ethernet, as well as it supports CAN bus, which is what's used in automobiles usually for communication. So again, I think you need another, like a transceiver chip you hook up to the ESP32, but you could use it to communicate with an automobile. And I'll explain in a moment what I mean by a module, which is a little bit different than this chip we see pictured, but the module, which is of interest, those are about $4, so that's what you're talking about. So if you buy one of these, or a few of these, right, can you damage it or you kill it somehow? They're not having a tremendous investment in doing that. So we kind of covered this, but here's a picture of an Arduino Uno board. So if you're familiar with that, that's very popular in the hobbyist community. And that uses an Atmel AVR chips, kind of like the AT Tiny that I brought up. This one's a little bit more capable than that AT Tiny, but again, it only runs up to 60 megahertz, has 2K of RAM, 32K of ROM, it doesn't have Wi-Fi or anything like that. So there's a bunch of applications where a chip like this would be totally useful, and that's the right solution, but it's just more limited in comparison to like what the ESP32 could do. And then on the other end, so if you think about like Raspberry Pis, they're popular to be used, but there's a bunch of trade-offs with that. Like a Raspberry Pi is a great device, but it's effectively just a miniaturized computer, right? It's similar to your desktop computer, but it's been shrunk down to a much smaller size. You can attach your keyboard and your mouse and attach your screen to it and so forth. But it takes a lot more power, right? Even though we think of it as being small, like you couldn't hook it up on a couple of alkaline batteries and let it sit in a closet for 6 months and expect it to still be running. We'd be lucky if it ran.
The day.
Well, yeah, for sure, right? But like with an ESP32, if you had to wake up every hour to read some sensor, and you then attach it to a lithium-ion battery, you potentially could have that ESP32 sit in a closet for 6 months and just change the batteries every 6 months. So it's orders of magnitude different in terms of power utilization, which is a key thing. And then of course, we just talked about the ESP32 module is $4 versus a Raspberry Pi, which is going to be like $35. And the last thing to mention is that when you think about microcontrollers, there's a lot of applications where you need the microcontroller or the control device to be able to respond to events in a very predictable fashion, right? If you're thinking about your controller in an airplane and it needs to respond to different aeronautical factors that would control the plane, you don't want your ship to get busy updating some display to the pilot, right, and not actually get that done in the time frame it needs to happen. And so microcontrollers, partially because they're oftentimes you program bare to the metal and it's much lower level, you get more predictability. And even when you start introducing an operating system, it's just you can achieve that predictability, which would be difficult on a Raspberry Pi in the common configuration, which is most people are running Linux on the Raspberry Pi. And Linux is great, but it's not designed for real-time systems. It just isn't. So, one thing I should mention, the ESP32, if you think about the technology in it, I mean, probably everyone here knows of ARM, so like a Raspberry Pi has an ARM chip in it. The ESP32 is neither an ARM chip nor a MIPS, which is another popular one. It's actually based on a core called a Tensilica LX6. It's a technology that, I can't remember, maybe it was Tensilica, but a company designed it and then sold it, I believe, to Cadence, which is like a semiconductor, or they make semiconductor design tools. And so when you are a Cadence customer, you can license that core apparently and include it in your product. So there may be other manufacturers that make LX6.
What was the name of that core again?
It's called a Tensilica. It's Tensilica.
Okay.
And the LX6 is the model that's used in the ESP32. I don't know, how are we doing on time, Dave?
Good as far as I know.
Okay. Well, I'll keep going and I'll head off to you shortly.
Sure.
So I had done this analysis a while ago, but I think it's really interesting, right? Which is just, the question I wanted to understand better is, like, when I think about these microcontrollers, how do they compare in performance in different situations, right? So whether this is the best measurement, it's one that you can apply across a lot of different platforms. So this idea of dry stone MIPS or DMIPS is a way to measure performance. And this gives you kind of an idea, right? So if we think about the Arduino Uno on the left, which I think I may have said that it should be a Atmega 328P, but the point is, the performance is 7 as opposed to the ESP32, which is all the way up at 600. So we have much more capability in terms of processing. And you can see, by the way, this is the 105 measurement. That's the ESP3266, so the previous generation that Espressif was selling. And then a Pi board, which isn't so important, but this one is based on a particular ARM core, so you can kind of see how that compares as well. And then thinking about that sort of upstream, this gives you an idea of where the ESP32 performance is relative to like a Raspberry Pi 3, which is running a higher end ARM core as well as 4 cores. And something I was trying to figure out is, like, how does this kind of compare to like historical hardware that we have on a desktop computer? And so just something I was able to track down is this gives you an idea of what the performance was in 1994 for an Intel Pentium. So basically what we're saying is, again, it's a little bit apples to oranges comparison, but it gives you an idea of kind of how the microcontroller technology compares to technology from 20 years ago, right? And the other key thing is that, 20 years ago, if you bought an Intel Pentium, it would have cost you a lot of money. It would have taken a lot more power than the ESP32 does. So on one hand, you could be kind of disappointed, like, hey, we haven't made more advances. But on the other hand, there's a lot of trade-offs. We've made advances not necessarily we've made advances in performance, but that's not the only characteristic to keep in mind, right? Cost and power usage are important too. Yep.
In 1994, my first PC was a 90 megahertz Pentium. I think I paid like $1,600.
Right. Right. Exactly.
And dollars.
Yeah.
All right. So I won't spend too long on this, but I'll just show you a little bit about. So if you were going to buy an ESP32, I wanted to give you kind of a little framework of the universe here. So we talked about, so I guess before I go to that, any questions about what we covered, like what it is, what we can do, and so forth? Good. So Espressif is the company that makes these devices. That's what ESP is short for. Espressif is a Chinese company. They're like a virtual fab, so they outsource their actual production of the silicon to TSMC or somebody else, right? And they sell a few different flavors of the chips they sell. So the ESP3266, can you guys see this, or do I need to like zoom my screen somehow? So again, since it came up, the 8266 This is an earlier generation product. It became available in like 2014. So again, it's fine to use, but I would recommend if you're doing something new is to focus on the ESP32. Not only is the hardware more capable, the SDKs and software development support is much more sophisticated for the ESP32 than it is for the 8266. And so you can buy a single core chip like you see pictured here, right? But that's not practical for, I think, any of us to use. Like I can't solder, I don't have a circuit board to solder that onto, nor is that within my capability even to do that. So I won't be buying chips. If you're making some kind of product where you're going to sell 100,000 units, maybe you would actually buy chips. And this is true for the 8266 and the 32. Maybe you would buy chips and use the chips. But there's a lot of headaches you have to deal with, like FCC certifications and various things. So that's probably not the way you'd buy it. I'll come back to that in just a moment. So, we've been talking about the ESP32, and there's a few different variations of that product that are available. They've been around since 2016, I believe. And when we look at those, and this is kind of what you don't need to read this text, but this is sort of what I summarized for you. We can see again a picture of it here, right? And so some models have dual cores. They sell single core models. They sell a model that has a small amount of built-in flash memory, so you don't have to go buy an external chip. So there's a couple of flavors here. This is probably what you want to focus on. This is what I've been talking about. And then just to mention it, they have a new product that I don't even know if it's actually released yet, but they call it an ESP32 S2. And this chip is, as I understand it, slots somewhere between the 8266 and the traditional 32. It actually has like more GPIO capabilities, which is useful for some people, but it's only available with a single core, so that it's going to be less performant potentially than just the normal ESP32. And like I said, I think this is brand new, so I don't even know if you can actually order this just yet. But
Yes, 7x7. I wonder why the one single core though. I mean, that's interesting.
well, it might have something to do with, so for one thing, this package is 7x7 millimeters instead of like 6x6, which could be for heat reasons, but it might also be that they've just repurposed the silicon space, right? So one capability that this has is it can actually work, notice it says one full speed USB OTG interface. So like the ESP32 doesn't have any inherent USB knowledge or capabilities, but this chip actually does, right? So it just may be simply that they traded off the space for the core to give it some other capabilities. I think I mentioned here, like, maybe it doesn't. Well, I mentioned earlier, there's some capabilities they've added too that you can use for like triangulation of location when there's multiple devices, and so that didn't work reliably with their earlier products, but they've done some combination of hardware and software to add that capability. So, there may be interesting things here.
And it says full speed USB too as well. Like
Yeah.
3.0 or something full speed.
Full speed might be in regards to like 400, 480 megabits, like 2.0 probably,
Okay.
because it should say super speed. I think if it was actually USB 3.0.
Oh, okay.
So then if the ESP32 S2 is the new latest and greatest, does that mean that the ESP32S was the
I don't think there was
greatest?
an ESP32S, so I don't know. I don't quite know the naming history, but this,
I think
but as
that's
far as
what
I
I
know, there's.
got.
Yeah.
Yeah, that's what mine says.
What's that?
That's what mine says. ESP32S.
Oh, okay. Well, we'll talk about that. Your board says that, but that doesn't mean the chip is an ESP32S.
Gotcha.
So let me explain that. So there's chips. This gives you kind of like the idea of the landscape of what the different products that are available are. But as I said, it's sort of impractical for any of us to get these chips and work with them, at least for at least a prototype kind of project.
I
So
don't
the
know.
next-
I've seen your soldering skills.
Getting better slowly.
It's
Yeah.
pretty amazing.
Yeah.
So the next thing upstream is there's these modules that you can actually buy. And a module is a little circuit board. It has this metal shield for RF reasons on it. But underneath these metal shields, there'd be like an ESP32 chip. And then there'd also be that flash ROM that comes with it. In fact, you'll see like this module that's a little bit larger. This one actually has one of those PS RAM chips, so it has extra supplementary RAM basically attached to the chip as well. So these are like, still may not be the thing that's very practical to deal with, and I'll show you an alternative in a second. But just be aware of these different modules. So just a quick survey of that. If you're focused on an ESP32 and you don't need that extra RAM, then this what they call W Room 32D is the kind of current generation, the current product that you would look at. And the trade-off is if you actually have that extra RAM, it uses some of the GPIOs, right? So you may have a project where those GPIOs are critical, and you don't want to sacrifice that. If you are, and also there's variants that as opposed to having a Wi-Fi antenna or Bluetooth antenna up at the top on the circuit board, so that's useful for probably most of our things where it's built in, but you can buy a variant that actually has a connector so you can attach an external antenna if you want to do that. And then also there's these what they call W Rover modules, and these are the variation, the same thing where there's one with an antenna and one without. The W Rover has that additional RAM chip built in that I was talking about. So there's kind of one last step to explain, but any questions, I guess? Any questions? Okay. So what we would probably want is a development board, right? Because if we're just trying to do an experiment, we just want something that kind of works out of the box that we can start messing with. And so there's a variety of different development boards, and I'm just on the webpage. They're not necessarily in the order that I would normally talk about them, but you can buy some more sophisticated ones. They sell one that actually has a camera built in an ESP32. So you could get something like this. We could look. I don't know the price of that offhand. The one that's probably more practical, though it's similar to what Dave's handing around, is what they call the ESP32 Dev Kit C. I don't know why that's the name, but basically that's a little board that has, you can see on the left, the module that I was talking about. And then in addition to that, it has a power regulator, so it can be powered over USB. It has it's called a UART to USB bridge, so you can actually attach this to your laptop. So not only are you bringing in power, but you can communicate with the device through a console on your computer. And then of course it has these pins on the outside where it's actually exposing all those GPIOs that I talked about, so you can attach things to it and actually do stuff. So this is, this particular one in the picture has female sockets on it. I think the one that Dave has male sockets, but they're available in both flavors. So this is probably what you'd want. And then if you have a more specific project, just to mention, like there was the camera that I showed you. There's one here that looks pretty, actually that's one. Yeah, they have one here that's really fancy. I think, I'll show you two. So a really fancy one is this one that's a Lyrat D. Like this particular board it's not Amazon Alexa, but it has like a voice recognition capability and audio features built into it, and like touch sensors or something. So they have other flavors that they've put out to help people understand like a reference implementation to use those kinds of capabilities. Probably not, maybe not the best place to start, but you could. They're not too expensive. And the last one I'll just mention, there's one here called a W Rover Kit. And what's special about that, you can't see it in the picture, but on the back side of this board, there's actually a little LCD display. And so this one has the LCD display, some additional, I think there's a light on the board you can control. There's both inputs and outputs that are already built onto the board itself that you can play with. And one additional capability that I don't know too much about but seems interesting is the traditional DevKit C. There's not an easy way that I know of to debug your code that you've loaded on it. Typically you run it and it crashes, and then you add some print statements and you figure out it's very not inefficient, I just would say. This has a special UART bridge that when in your computer it will show up as two devices. One is the normal console, and the other is like a debug connection that with the right tools you can actually pause the code and separate points and do different things. So, okay. Where does that leave us? Oh, last thing just to mention, you can buy these are the modules, but you can go to DigiKey or go to Mouser. They both are distributors. I guess I could zoom in here. Not a big deal, but just to show. So this is where you can see that they sell the different models of things that we talked about, and they're, $3-4 for the modules, and then like if we were to look up a DevKit C.
I think I got mine on Amazon for like $9 or something.
So I will say there are, the situation was much more messy with the 8266. With the ESP32, Espressif makes reference boards, but there's lots of third parties that buy chips and make boards as well. Some are very close. And the design of at least like the DevKit C, like the schematics and stuff, I believe are available from Espressif. So you can find other ones. as an example. This is the, so here's one of those boards on DigiKey, which they don't seem to actually have one at the moment, but that doesn't matter. But you can come to DigiKey or Mouser. I don't know why I'm not seeing one that's actually, some of these say obsolete, but you definitely can buy development boards on DigiKey. So you can find ones. They're like $10. So that's sort of the price point. If you want to get one of these, maybe you can find a third-party one from somewhere for a few bucks cheaper. If you want a real expressive one, you can get them for as little as $10.
Amazon, yeah. Amazon.
Yeah. Arrow does not, last time I checked, sell any of these expressive parts. One, not to make a big deal about it. So right when the first ESP32s came out, they were on Silicon Rev 0. This was a few years ago, and there were some defects that got fixed, and then they eventually made a Rev 1. So one thing I did notice, and if you're just starting out, you maybe don't care about this, but like you would think you were going to get a Rev 1 board. Like I got some from Amazon that were old stock clearly because they were like Rev 0 boards, even though Amazon said otherwise, which was just sort of annoying. I will tell you that recently somebody's figured out how to compromise some of the security controls in the ESP32. So I understand that they'll be coming out with Rev 2 silicon soon to mitigate those. I mean, probably nothing that, if you're just starting out, probably, I can't imagine you would do anything where those security controls are a big deal because they still work. You could test them out. It's just there's an opportunity that they could be compromised. Okay. And the last thing I was going to share, and I'll give it to Dave, is just to say, so this is sort of a picture of an ESP32, one of the modules that we talked about, right? And so if you had like a dev kit C, a development kit board, the things that you see coming out of this module are exposed on those external pins so you can use them. But what I wanted to highlight here is that notice that they have figured out how to give multiple purposes to many of the pins. This is some of the confusion of, well, how many GPIOs do I actually have? It depends what you're trying to accomplish. So for example, on the right here you can see in this blue color, there's these references to EMAC. So like these are pins that are dedicated to that Ethernet functionality I mentioned. So probably most people don't use those, but the project, for example, that Dave and I'm working on actually does use Ethernet. So those pins are not, some things you can reallocate and choose other pins for purposes, but like the Ethernet pins are locked in. Those are not configurable. So like if you were using Ethernet, those are off the board. Also, in this picture, some of the ones at the bottom here, some of the pins actually are connected, I think, to the flash memory. I'm not sure which ones offhand. And so you do have to sort of be aware of those. And you need to, yeah, so these different, so this is, all these boxes are just basically showing the multiple purposes of things, right? So one more example here is, so sort of where it says 5, 8, 10, 11. Notice on the left it says like RTCIO 0, RTCIO 3, etc. So that's in reference, like those are the pins that are only inputs and not outputs, and they connect to that ultra low power processor core. So you can look at this if you're actually wiring something up. It's important to understand what the what's going on here. So any questions about that?
That board was the first time I ever saw GPI without O.
So I don't see it printed on here, but I do think in the expressive documentation they use the term GPI.
Yeah.
But for sure, it's a good way to think about it because if you design a board and then you expect to output something on those pins, then that would be a problem. It's not going to work. So, yeah. And you can kind of see here too some of the other capabilities. So like all these the green boxes say ADC, so you can actually, all these pins have analog to digital conversion support. There's also, I don't know where they are, but there's some pins that can be used for digital, orange pins over there, digital to analog conversion. So, and there's touch pins, there's pins, so if you want some sort of capacitive touch where you touch a pad or touch a wire and you want it to do something, you can wire up some of the input outputs to do that. That kind of gives you an idea of the different capabilities that exist. So, do you want to come?
Yeah.
Or I said, well, yeah.
Oh, we're done?
Yeah, I'm done.
All right. Awesome, thank you.
I don't know if you're gonna come up here or sit back there since you.
Yeah, I can airplay. I can do this from
Yeah.
back corner.
Chair.
All right.
Dave, you gonna do code stuff?
Yeah.
Okay, that was gonna be my next
I'm
question.
gonna need this though. Stop it.
That jingles.
He gets that from his father, I keep telling him.
Yeah, kids.
Hey, it looks like some kind of medallion that
Oh,
you
too
wear.
tall for this thing. There we go. Much better. Okay, can you see me now?
Not yet.
Kinda hidden behind the podium, I can't see it, dude.
Am I blocking the screen?
No.
Cool. And the code is 1523. And there we go.
Nice.
What is all that at the top? Oh, it's not because it's on my screen. There we go. Okay. The compiler suite and tools for the ESP is called ESP IDF, and you can learn more than you've ever wanted to know about that by visiting docs.espressive.com website. I don't know if you can see that; it's pretty small. But, basically, once you get there, you just click on Get Started. The suite is available for all of your major platforms, Windows, Linux, and Mac. In my case, I installed it on my Mac, and there's actually two pieces to it. There's the ESP IDF piece, which is the compiler tools, and then there's a second piece, the ESP IDF is the compiler suite, and then there's some additional tools called Sencha tools that you need to have installed in your machine as well. And the documentation on this page is very thorough, and it'll walk you through everything that you need to do to get it all installed. A couple of key things to remember is that although you can put both the ESP IDF compiler and Sencha tools in any directory you want, you always have to remember to go back and make sure that your paths are all set. I'll show you how to set mine up in a second here. So if we come here, can anybody see that? No.
I'm right next to it, I can't read it.
Alright, let me see if I can make that bigger. I should have thought of this while I was sitting there watching Darren.
Well, my presentation was written.
Yeah.
Hey Dave, is your password supposed to be on the screen?
Yeah,
Okay.
that's for everybody to share.
I can't read.
Yeah, you can't even read it. Hey, alright, how do I make this bigger here? Text.
I thought it was just Control plus plus plus.
Let me try that.
Command.
You're on a
Command
Mac.
plus plus.
Command plus.
Oh, yeah.
There we go.
Sorry.
It's that easy. Thanks.
You have to tell it what to command it.
You get the door practice.
I think after is like a little friend does. Do it on this one as well.
Hey, that's a really boring looking bash prompt, by the way.
Can we put more color in that?
Okay, there's color on the bottom.
That's not enough.
Okay, so now can you see it, or should I go
Yeah,
bigger?
I can see it.
You good in the back? All right, here we go.
Yeah, right.
I happen to put my ESP IDF directory in /opt on my Mac, but again, you're free to put it anywhere that you choose.
Trash can?
That didn't work. I heard that.
As long as it's an Apple trash can, yeah.
I thought I did. What's
That's
going on
cheap.
here?
Well,
You sure it's not in your home directory?
So you gotta
Is
get
it maybe?
I thought that's where we normally set it up.
There's one quick way to find out, and I was going to show you that too. Is
make one that looks like a
yeah,
printer.
D&D.
Press the vision, for instance.
Dash profile. That'll tell me where its path to.
Well, maybe there's another one that looks like a toaster.
Oh,
User local.
Yeah, code.
Yeah, log that.
User, oh, it's in user local. I'm sorry, I lied. No, that's the extensive tools.
You know, it doesn't post.
Oh, Extense is the company that originally made that 10 silica core. That's where that name comes from, by the way.
Well, eventually I'm going to have to find it because that's where my sample is. I don't know how this happened. I could have sworn it was is it, how can I get, to see what my path is for the ESP
Echo
idea?
path.
ENV, yeah,
I bet you in my home directory, I got a symbolic link, don't I?
ENV, Brett.
User local ESP IDF. I did lie, I'm sorry. So let's go there. User local. There it is. ESP IDF. And again, I'm not seeing what I'm expecting to see because I have 3.2 installed. I apologize here, I'm totally lost. I don't know where it went.
Are you just building the stock example?
Yeah.
So it should be under 3.3, right? Is it?
I thought it is. Oh, you know what? It was on my Linux box at home. I was in 3.2. Sorry.
Okay.
CD 3.3.
Ah,
Actually, Dave, I think when you're looking for
Tools.
sudo rm-rf /.
Oh, okay. I'll try that.
Yeah, make sure you put a space between, yeah, make sure you put a space between the period and the slash.
Personally, I like doing sudo su.
So I'll just say while Dave's doing this, the IDF, which is this SDK that Espresso provides, comes with a pretty extensive set of examples that do all sorts of things, ranging from web stuff to controlling peripherals like screens or whatever. So there's a lot of sample code to work with, which is quite helpful for sure.
hello world, probably.
Now, did you mention something before about C? Is that all of the programming for this board is in C? Or,
So
because
there's,
C++ has a lot
so
of.
there's a couple options. The SDK that's part of the IDF is primarily written in C. There are some components included that are C++. So if you wanted to write C++ code, compile it and deploy it, you definitely can do that, right? You can choose either.
Okay.
That's like the official supported way of programming, but there's a lot of other options. So one option, by the way, is if you know something about like the Arduino IDE or that Arduino ecosystem, you can install the ESP32 core, which they refer to cores in the Arduino world to support different platforms, and you could do all your development with the Arduino. You'd still be writing C code, but you get another set of stuff. Definitely do that if you're interested. The downside of that, just to know, is like the commercial project that Dave and I have been working on. Well, you don't want to do commercial projects with Arduino because all their stuff is GPL licensed, so you'd be obligated to release your source code for whatever you did. But that is an option you can use, work in the Arduino ecosystem. And then there's a variety of other people have built other languages that can run on these devices. So for the one that I'm most familiar with is MicroPython, which is a version of Python that runs on microcontrollers. And so effectively, like MicroPython is written in C, and it's built using the same stuff that Dave's going to show us here. But then once you deploy it, you can actually run Python code on your device and control all your embedded stuff. It's really cool. I would definitely suggest checking that out. And if you're just beginning and you're like, I want to try this out, and I don't know C, like there's a lot of complexity to deal with C and understand what's going on. It's hard to debug. Like definitely, hopefully someday we'll do another talk on that, which is MicroPython, and it runs on multiple platforms, but you for sure can run it on this platform.
Yeah, and I programmed it in both C and Arduino. It was kind of neat when I discovered that you could switch between the two on the same hardware. I even I flashed it with the Arduino IDE, and I've also flashed it using VS Code, which is pretty cool too. Okay, I finally found what I'm looking to be here. What I did was the ESP IDF comes with a whole bunch of different examples, and I went ahead and grabbed one of those and made some slight changes to it. But I'm going to walk you through what an average ESP32 program looks like. So I'm in the directory for HTTP request, and I'm just going to open that up in VS Code. And there are a few things that are pretty common to all.
You might need to zoom in.
Especially on that bit on the right.
Hold on, I see.
There, is that better?
Yeah.
That's too big.
Security.
He's very insecure.
That's it.
So,
3 strikes, you're out. There are several common elements to an ESP32 program. One is main directory, which has in it your main.c file, which is your actual start or the core of your program. Additionally, there is some information on in the make file here, generally a README, and the SDK config, which is like test-based configuration options that I'm not completely familiar with exactly how these work, but I'm going to show you how to configure your program in a little bit. So let's take a look at the main.c here in this case. And what we're doing here is, I don't know how familiar anyone is with C programming, but at the top of a C file you have all your includes. Here's where you're including all the libraries that you're going to use. In our case, we're using some libraries from FreeRTOS, which is a real-time operating system. Some of the ESP prefixed library or header files are in here for different things. One most notably is the Wi-Fi.h, because the sample I'm going to show you is using Wi-Fi. And the LWIP headers, which also have to do with networking. Then we go down a little bit. What these all uppercase lines do is these access values that are stored in your configuration under the same name. And again, I'm going to walk you through how to do that configuration shortly. Go down a little bit. Now when I started with this sample, it was originally calling example.com just to prove that you can make an HTTP request. So I thought that was a little boring. So I went online and I actually found this URL. And what this does is it sends back the current location, geo coordinates where the International Space Station is. So what this program is going to do when it runs is every second it's going to hit that API and echo back what the current coordinates are for the space station. Let me go down a little bit. Then we have the event handler. This is part of the this is what gets called when on events for the HTTP call. Calls this function, and you'll see that there's different events that trigger different actions in here. In this function, we're initializing the Wi-Fi, going ahead and connecting to the pre-configured Wi-Fi SSID and password that I've already entered. But again, when you show you the configuration step, you'll see where that gets entered. And then here it's reporting setting Wi-Fi configuration SSID. And we're going to see that echoed out at the terminal. Every line that you see that goes ESP_log is a line that echoes information back to the console. And we're going to see that in action in a moment. This is the function, I believe, that performs the actual GET to call the API. Yep, it's going to web server here, port 80. It's doing a DNS lookup on the URL. Then it resolves the IP. You can see that I commented out a whole lot of these log lines because it was creating too much noise as they were going by every second on it. I wanted to focus on the data that was being returned from the API. If something goes wrong, it logs that too. In this case, failed to allocate socket if there's a socket error. God bless you. Or if it has trouble connecting to a socket, it'll report that error as well. Connects. If there's a sending error, it'll report that here. And excuse me. Then we get down to reading the HTTP response. And this is where the response gets parsed, and each receive buffer for display to the console. And now every program, every C program has what's called a main function, and that's the main function is the function that gets called first when you execute a program, and then it's inside of main that everything else gets called. And you can see our main function is pretty sparse, and that's actually the best practice. You don't want to have a whole lot of things, everything happening in your main. All you really want your main function to do is call other functions. And that's exactly what this is doing. The last notable piece here is this xtask create. That's a function of the free RTOS library. And what xtask create does is it spins up a completely separate thread for the task that you're giving it. And in our case, we're giving it HTTP GET task. And that will then run in its own separate thread, which is managed by free RTOS. So, yes, sir.
So I made the point when I presented that a lot of times with microcontrollers that we don't have an operating system.
Yeah.
Put you on the spot, but can you explain for a moment why we need free RTOS for the ESP32?
I think I know that.
Okay.
The reason we need free RTOS in ESP32 is without it, we would not be able to do threading and have thread management.
Right. So the key thing is because we have multiple cores, we need some basic primitives to leverage those cores, right?
Exactly. And do you aware of a better or additional reasons for free RTOS?
Not specifically, other than it should. But the key point being is that when you have like a real-time operating system like free RTOS, it's nothing like Windows or Mac OS. It's like a very, very tiny thing with a very limited set of primitives to coordinate activities between processors and cores, and that's a useful thing.
And isn't it not only just managing between cores, but isn't it also threads on those cores?
Well, yeah.
Power.
But you could build useful stuff without. I mean, you can like on the ESP32 it does not. It has different SDKs. One of them, the most popular one, the one that you use with Arduino, does not actually use free RTOS. But because it only has one core, you need something to help coordinate. If you're gonna have threads, you need something to help with that. If you have multiple cores, you need to help coordinate that. So yeah, you need to start adding some bits to help with that.
Sure. So, without any further ado, I'm going to go out to the command line now, and we're going to actually see this thing in action. People stop calling me here. All right, so that's going to be over here, and I mentioned earlier about your configuration options. Another part of the ESP compiler and tool suite is semi-graphical configuration utility called menu config. And the way you do that, now you can do this for any ESP32 program that you've written in C. And it's just simply make menu config. Like I said, kind of semi-graphical here, kind of 8-bit DOS-y graphics, but there's all kinds of different things you can set in here. We have the SDK tools, which is your Extensa configuration settings, tool for your tool chain, Python interpreter, an option for make warn if you have any undefined variables.
That's interesting. It said Python 2.
Yeah.
Ooh.
Yeah,
That's run out.
that's going away real soon. Finally. It only took a decade.
Yeah, I don't know what their plan is to deal with that. I don't know why that's taking so long.
Now is that evolution going to occur in it's going to occur in ESP IDF? from 2 to 3?
I would assume that would be on their to-do list, but I don't know.
Because I know that this is an older unit now. I think this might be your.
Oh.
be your
Well, the Python 2 has nothing to do with the device you have attached. It's just that some of the tooling scripts that like do the Flash deployment are written in Python,
Mhm.
and so they just haven't ported that, I guess, up to Python 3 yet. I don't know.
So yeah, some options here for application.
The thing you might show is the component config. So the SDK comes with many capabilities and libraries, and this is where you can go in and turn on and off certain libraries and or change their settings. So there's like LWIP is the lightweight IP protocol, so it's the IP protocol stack, and you can see there's tons of stuff to affect the behavior or affect how it's memory utilization and all sorts of stuff that I don't even understand.
And this is also where I came in to pre-enter in my Wi-Fi SSID and password. But there are a whole bunch of other Wi-Fi settings in here too. There's some power management settings, some HTTP settings, settings for the free RTOS.
Oh, wow.
So yeah, there's many things that you can configure, and also now Christopher's better at this than I am, but he knows a way that you can add and remove these, right, Christopher?
Sorry.
You said it. I said it. You know a way to add and remove these configuration options too, right?
Yeah, this menu config system is configurable, so you can build additional menu options for your specific project. In fact, this one had some. So if you do exit, and exit up one more level, you should see it probably says like that example configuration. That is added in because of this project defined these attributes.
And this is where I went into. You can see we're on the Capital Factory members SSID on their Wi-Fi. So that puts this device on the Wi-Fi as well as my laptop.
Are there any of those settings that are not in? I'm blanking on the name of it. There's a regular text file that defines that. So you could copy the text file from project and just put those settings as it's not.
Yeah, so, well, go back to your Visual Studio Code just for a second.
SD config.
So all the settings get stored in they're just name value pairs in a file called SDK config. But this is a best practice, what I'd say, if you make a file called sdkconfig.defaults, you can, because you probably don't care about some of these settings. In fact, you probably want them to be the defaults that Espresso's defined. And if they change those defaults over time, you probably want to pick up their changes. So the things that you definitively care about, you should put in sdkconfig defaults, and it may just have half a dozen entries. And what'll happen is the first time you run make menu config, it'll basically use that as the starting point to manage the SDK config.
Okay.
So,
does it force you to use the make menu? Because I've done it before without ever running that, just using that config file, just manually editing it, and I don't.
So if you already have an SDK config file and you do make, it won't do anything. If you do it the first time and that file doesn't exist, then it'll bring up the menu config automatically. But if the file's there and you don't say make menu config, it'll just use whatever's there. Yeah.
So yeah, I've been scrolling through this as you were explaining that. You can see that this is very lengthy. Many
How many
options.
lines total?
Yeah,
A lot.
720 in this one.
So the nice thing is, I don't quite know the process of this, but when you build your software, it takes this file and generates like an include file. So like your Wi-Fi password will be in here, like we were showing, it was in here somewhere, but then the code was able to actually reference it, and it's not reading the SDK config file, it's reading a header file that was generated from SDK config. And that would be like, if you look in the build directory, that's where all the build outputs are, and one of the build outputs is the header file, I forget the name of it, but.
Okay.
Cool. Thank you. All right, so I gotta exit out of that. Or did I already? Yeah, I think I did. Okay. So that's the configuration area, and what I'm going to do now is, because I've already built this, you can see I have a build directory in here. I'm just gonna go ahead and delete that so that we can witness an entire compilation process.
That's very exciting.
Make clean, make clean.
You can do that.
Instead of just deleting it.
Yeah. There are situations I've seen where if you do make clean and you've like upgraded to a new ESP32 version, like it doesn't always delete all this. So there's like a mismatch. So you do have to be careful when you upgrade IDF versions. You might have to clean out the build directory manually one time.
Alright. That's how I've always done it in JavaScript.
Wait, did it delete config? It says like rm config on one of the lines.
That's I think probably inside the build directory. I don't know what that file normally contains. That's not, so SDK config in the root in the parent directory is what contains those menu config options, so it didn't delete those.
Yeah, it left all kinds of stuff in the build.
Yeah.
That's what it's looking
Too.
Well, you can, when you do a new delete it is fine, but make clean typically works fine as well, so.
Alright, so what we're gonna do now is make our example here. And it's just does a standard GCC-esque make as you watch it scroll by.
So while this is building, maybe just one more thing to add. So the ESP IDF you pull down from Git, and it's always evolving, right? So the master branch is the current work that's work in progress. And so like a week ago, I tried to pull down their latest version, and make menu config just plain failed. And I concluded it was something on their side, right? So they're working on coming out with, it seems like there's branches for version, they're working on version 4 and 4.1. So the version we're using right now is ESP32 3.3. So I would suggest if you're gonna do development, get the latest stable version, which is 3.3. I mean, that'll change over time, but just be aware, like I didn't realize that a few months ago when I started some of this work, and I pulled down the current branch and like Wi-Fi was broken, and I spent hours like, why is my code not working and what is going on? I was completely perplexed, and I just didn't understand, like they're not diligent about making sure, I'm not saying this is wrong, but I didn't understand what they were doing, and they're not diligent about making sure that whatever's in the master branch is always like functional and everything's working properly. So if you don't care about the very latest stuff, stick with version 3. And then the other thing to know is, it's all documented, but the setup procedure for version 3 and version 4 is a little bit different. So just be aware a lot's changing with version 4, it looks like, and the way you set up the software is a little bit different to getting started for the setup process.
I had problems with 3.3 trying to get an Arduino library integrated using their setup. It could have been me, but I just tried all their instructions and couldn't. I just went to Platform.io and used that integration.
I've not used Platform.io, but I have, maybe you've used this. I heard there's a way, or I read about this, you can, like, maybe it works both ways. Like, you can encapsulate your IDF project inside Arduino, or maybe inverse what you're saying is, I have an Arduino component and I want to run it.
Right, I just went to that library, it was a Max 31855 or whatever, and I went to that library, and I just could not, their instructions for 3.3 just were not working. I might have
Sure.
I don't know.
Yeah.
One cool thing I like about the ESP IDF is that normally with a software package, when they update it, you gotta go download the update, reinstall it and everything, but in this case, when they come out with a new version, all you gotta do is just make sure you pull the latest code, and then you just check out the next tag. So actually, if you have the repo clone on your laptop, you actually have every single version right there, and you kind of switch between them.
Can you zoom in a little bit?
Oh, sorry.
Well, it's okay, but yeah, it was just so you can kind
I
of
keep
see here.
thinking everyone is standing right in front of it.
Like you are, yeah.
So these are the tags in the repository, so you can see, like, because it just says version 3.3, we know that's stable because it doesn't say anything after it. Notice, like, there's a 4.0 and a 4.1 dev, but or actually I see 4.0 beta 1 and beta 2, so maybe they're close to releasing 4.0, I don't know. But those are not the stable versions.
So yeah, as long as you have everything pulled current, you can bounce around between these just by checking out whichever tag that you're interested in. What I'll do sometimes, I'll clone it in one directory, I'll check out the v3.3 tag, then I'll clone it again in the directory right alongside it, the exact same code base, but I'll So, getting back to here, our make is done. The next thing we need to do is flash it to the device here, and that's pretty simple too. I'm sorry. I think I heard that. For the longest time, I was just doing make flash to flash it, but then I was reading some documentation, and if you add the -J4 to your flash command sequence, I guess what that does is it utilizes multiple cores if you have them. Makes it a little bit faster.
I think actually, I'm going to tell you this way. I think of that backwards. You want to do J4 for the compilation so it can compile on multiple cores. The flash you're limited by your serial connection anyways.
I thought it said J4.
That seems odd, I would say that, but
My card is about to expire, but I wanted to, do you have a card or something? I would contact you later. I have a few questions.
I'll just email it. I'll try to drop an email.
That sounds great. Yeah,
Oh, yeah.
appreciate
Oh
it.
well, I'll figure that out.
Thanks for coming.
Yeah, thank you. Good later, man.
I could have sworn it was in the flash step where it said to use J4. Unless they were doing,
Maybe there's a typo somewhere, or maybe, I don't know.
you'll have to come back next month to see the answer to that question.
And by the way, notice like in actually the documentation you're looking at, see how it says like idf.py menu config?
Yeah.
So this is an example where this is different because this is the 4.0 documentation, not the 3.3 documentation. So in your URL at the very, well, it just, yeah. Just know that this,
Master. it
because
says
we don't
master.
use idf.py, that's a new 4.0 thing.
Oh, there, J4.
Okay, that's, oh yeah, make
Well,
J
that's
right
compiled.
there.
Hmm.
Make
That
J
seems odd to me,
for
but
flash.
okay.
Cool.
So, back to here.
We should test that out, but
I mean, it's a little bit faster. It might all be in my head. I just might be imagining it's faster.
So you can just time it. Put
Yeah,
like time in
with or
front of
without.
it, and then it's gonna show you like how long it takes.
Sure.
Like in front of the command, put time, space.
Sure.
so one thing to mention here, and I don't know about your specific board, Dave, but some boards, so you either have to boot your device like in, you could think of it as application mode or like in like flash mode. And so some devices are wired in such a way that this tool can automatically make it reboot and it's automatic. But if you have a device that doesn't have that for whatever reason, there are some buttons typically on the dev, like the little dev board, and you kind of hold down both of them at the same time to put it into flashing mode. So I don't know, do you need to do that on your board or is that not?
I didn't have to do it
Yeah,
before.
try
I
it
don't know
on
why it's
J4.
Oh, no, I got many commas off.
So that the periods and the underscores indicates it's, well, it says connecting. It's trying to connect, but it has not connected, so it's not flashing just yet.
Oh, the reason it's not connecting is it's a live demo. That's why.
My live demo worked just fine.
Are you still here?
We've said that for 30 years.
Your mom's calling.
It's right there.
No, she's not. She's right here.
Actually, I had to clean up after him in her basement.
Yeah, because he followed the sign.
So does this
Well,
have to use-
anyhow, that's how the make or the flash step works, and that flashes the code over to the device, and
Yeah, it all worked good, yeah, yeah.
and what the moment we've all been waiting for. Oh, also, the ESP-IDF has a built-in monitor console function that you can invoke when you run it, so you can see what's happening on the screen. And
Perfect.
Nice.
now let's look for where's the coordinates should be coming. There it is. Here's the coordinates. They come by every second, and if you'll notice, let me make that bigger. As they're going by, you can see that they're changing. Because obviously the International Space Station is moving. Can everybody see that?
That's better than NASA using Nginx.
Yeah, right. There you go. Yep.
That's pretty cool.
And if you're ever bored late at night and you want to know where the International Space Station is and whether or not they're spying on you, you can go there and find out.
Hey, they're trying to bake cookies right now.
Who's-
The ISS.
Really?
Yeah, they're trying to figure out how to bake cookies in space.
Awesome. I want some.
Why would that be a problem?
Gravity.
Zero gravity. There's no convection.
They would come out like donut holes.
No,
Well, the Italians figured out how to make espresso in zero gravity. That's
right,
pretty
but zero
impressive.
gravity, because there's no concept of up, means there's no convection. So hot air doesn't actually go up because there is no up.
Man, now I thought I was going to get some
Put a
sleep.
fan in
tonight.
it.
No error, yeah.
No way.
All right. Anybody got any questions?
It's a good demo. I'm glad it worked. I mean, yeah.
Thank you. Questions, comments, dirty remarks?
Oh.
It's slightly less boring now.
Yeah. 12%.
Did you say there was a way to flash it directly from code, VS Code? There's a capability, but this is easier. This is probably easier.
For the purposes of this demo, I did it this way.
Hey,
VS
Dave.
Code does have a bash prompt built into it if you're running
Right.
on
Hey,
Linux
Dave.
or
Yeah.
OS X.
Sorry. Hey, can you put this code up somewhere?
Yeah.
Okay.
Yeah, sure. If anybody wants a copy of the code, just let me know. I can get it to you. I can see about maybe, I don't know, if I can post zips in Meetup or not.
Just
You
give
have
us
a GitHub
But
account.
it's like straight from Git, isn't it?
What's
Well,
up?
he
Isn't it
modified
like
it.
straight from,
Well,
how
he
much did
modif-
you modify it? Push it as a branch, make it as a branch, post a link on Git, on.
All right.
The only modification you made was commenting out a bunch of lines.
Commented out a bunch of lines and I changed the URL for the API endpoint.
Then the password.
And, oh yeah, well, that was in the configuration, but, all right. Any questions? That's it. That's all I got. Thank you.
Which
If
you
any of
like,
you are,
orders every single time.
The speed of the space station with this program,
I'm sorry?
how would you,
Yeah, I thought
the
about
speed
that.
of it,
When you can't calculate the speed by the variance between the latitude and longitude using some trigonometry,
well, that's a
geometry,
no.
it's a little bit of work, but yeah, you could, using these numbers, you could go ahead and overlay out a map.
Oh, yeah.
You need to know its altitude though, right? Maybe that's fixed. Is it fixed?
Well, the altitude's pretty consistent.
I don't know if you would need the altitude to plot it on a 2D map though, based on the geocoordinates.
Oh, no, if you plot it on a map, if you want to know
Faster,
how
yeah.
fast it's traveling.
Just do that.
No, because it would, your speed
is just
would
your-
just be
it's
the
just a measure of your
distance
over
and
time.
I
over
think the
time.
accuracy might be.
not high.
So, in this particular case, you would actually use the Haverside's formula to be able to determine your speed. Because Haverside's formula is the distance between 2 points on a sphere. So as a result, you'd be able to you need to know the arc of the sphere and be able to know position 1, position 2, and the distance on that arc between those two
Yeah,
positions.
then you'd have to know the altitude.
Because otherwise you're talking about a bigger sphere.
Yeah.
Yes.
Right.
Alright,
So if any of you want to work with the ESP32 and this wasn't enough, come to the Austin IoT Slack channel where we can answer questions, or if you need help getting started with getting things set up, I even have some scripts to help automate that. I actually like set up my ESP32 build environment in a virtual machine and I have it all automated, so I'll be happy to share that if it's of interest.
awesome, thank you.
All right.
Alright, then I guess that's it for this month. We will not be having a meetup next month because I think next month our meetup would probably land on Christmas Day.
That'd be awesome.
Yeah, it's
Unless you're prepared to bring gifts, we won't have a meetup next month, but watch for us coming out again in January. What's that?
It's for Boxing Day.
Yeah.
There you go.
Alright, thanks for coming. Be safe.
Thank you.
Happy Thanksgiving,
Now I
everybody.
say be safe. met me 32 years ago.
You.
You're the one who said you should have spent 50 cents like a quarter.
That was me.
That was the first time
That's right.
Yeah, well, that's not a bad thing, right?
Thanks, Steve.
Yeah, so thanks for letting me interject.
Oh, absolutely.
Yeah.
We kinda did a bit of a good tag team there.
Hey, did you say dinner was at 2 o'clock?
Yes.
Okay, I might have to move my schedule around a little bit. Okay, but no worries, I'll bring that pie over first thing in the morning, okay? And the pot, and
So are you inspired to do some ESP32?
Thanks, buddy. I will, and go back through the examples, like Hello World is in the examples,
Yeah.
and
There's a whole